Number 4-4, factoring trinomials, day 2. Let's go ahead and use the blocks and boxes method in combination with the sums and products method to factor out these. So we can draw our box, fill in what we know. We've got an s squared and a negative 30. We need our sums to, multiplies to. In this case, we're going to multiply, or sum to the middle term, negative 13s, multiply to the product of the squared term and the constant term, or the c term, negative 30s squared. So we need to think of two numbers that are going to have a difference of 13 that multiply out to 30. In this case, we can work out with a 15 and 2. We've got a 15s and a 2s. They have a difference of 13. We want a negative sum, so we're going to want the larger expression to be negative, so we need a negative 15s and a positive 2s. We can go ahead and fill in our box where we need to, the negative 15s and the 2s. If you notice that these sum up to our middle term, and they multiply out to the product of one diagonals. S times s will give me the s squared. S times negative 15 will give me the negative 15s. And then s times of positive 2 will give me that 2s, positive 2 times negative 15, the negative 30, so we could write this as s plus 2 times s minus 15. Okay, now let's work on number 2. We've got a 5q squared minus 3q plus 5. We've got the 5q squared and the positive 5. We use the sums to and multiplies to. Now we need to multiply out to 5 times 5 is 25, so we've got the 25q squared, and then need to sum up to the negative 3q. Now if we have a positive product and a negative sum, both of our terms have to be negative, so they're going to add up. So let's think. We've got 1 and 5, or 1 and 25 rather. They multiply out to 25, or q and q, but they would not add up to negative 3q. The only other factors are 5 and 5. We've got the 5q and the 5q, the negative 5q, but that would only add up to negative 10q. So we couldn't break down our middle term into two factors. So what you'll notice is that we won't be able to factor number 2 any further using whole numbers. We'll get on to factoring with decimals and finding the roots of this, and we'll get onto that in later videos. But for the purposes of whole numbers, there's nothing we can do to this. So in factored form, we just have to write a 5q squared minus 3q plus 5. So we have no whole number factorization, so we can think of this as prime, since the only other factor we could factor out would be a 1. We can't break this down any further, so it is prime. If you notice, like, let's say 7 can only be broken down into 1 and itself. It is a prime number. This is the prime factorization. Now when we think of factoring, we think in whole numbers, so that's why we don't factor with the decimals. We'll get into that later, but for purpose of this lesson, we'll just work with whole numbers. So let's work on number 3, see if that one can be factored. Let's check it out. We've got the 2r cubed and the negative 14 that we can fill in. Sums to, multiplies to. We need to sum up to our middle term, which in this case is a positive 3r. We've got the 3r. And you need to multiply out to 2r squared times negative 14. We've got the 2r squared times negative 14 makes the negative 28r squared. So since it's a negative product and a positive sum, we need our larger expression to be positive, and they need to have a difference of 3. I can think of 4r and 7r. If I were to subtract those, I would get 3r. But I need to subtract, so one of them has to have a different sign. We want the positive one to be larger, so 7r will be the positive one. We've got negative 4r. Negative 4r plus 7r, 3r. Multiply them out, you get negative 28r squared. Let's fill in. We've got the negative 4r and then the 7r. Now if we were to factor along here, we could get a 2r. 2r is the greatest common factor of 2r squared and negative 4r. And then along here, well, if we multiply 2r by r, we get the 2r squared. 2r times negative 2 would give me the negative 4r, and r times a positive 1 would give me that 7 I need. So So let's check. 2r times r, 2r squared. 2r times negative 2, negative 4r. R times positive 1. Or rather, sorry, I made a mistake, is 7. My apologies. R times positive 7, 7r, and then a positive 7 times a negative 2, negative 14. We've got the 2r plus 7 times the r minus 2. And I'm kind of bleeding over here. But we've got the 2r plus 7 and the r minus 2 as a factorization of number 3. Let's look at number 4. Go ahead and draw your box, fill in what you know. We've got the 10y squared, and then the positive 7. Our sums 2, multiplies 2. We need to sum up to our middle term, which is negative 19y in this case, and multiply out to the product of the square term and the constant term. We need a 70y squared. They're both going to have to be negative because they need to multiply out to a positive number but add up to a negative sum. So we need to think of two things that would add up to 19. I can do 14y and 5y, but again, they both have to be negative. Negative 14 times the negative 5 would give me the positive 70 I need. Y times y squared. Add these together, negative 19y. So fill in where you can or where you want. You could put the 14y here. Doesn't matter. Now, we need to think of factors along here. Let's think. We've got a 5y. And then if we're going to multiply 5y by what to get 10y squared, we need to multiply by 2y. The y times y squared, 5 times 2 is a 10. And if you notice here, we can factor out a 2. Now from here, what times 5y would give me negative 5y? Well, in this case, a negative 1. And then what times 2y would give me a negative 14y? Well, a negative 7. Negative 7 times negative 1, positive 7. So in factored form, you could write this as 2y minus 1 times 5y minus 7. There's our factored form. Now, we've got factoring the following trinomials. Now, if you notice that we no longer have just one squared term, we have two squared terms when we have more than one variable. But it's okay. Our sums and product blocks and box method still works. So we'll fill in our squared terms diagonally. So we've got a 4y squared and a negative 3x squared. So far so good. So let's think of our sums 2 and multiplies 2. Let's think. So we've got the sums 2. Since we're going to end up multiplying these, if you notice, in our blocks and boxes, we've been multiplying the diagonals. The only thing we haven't done anything with is the middle term, which in this case is 4xy. If I multiply 4y squared by negative 3x squared, I'll get a negative 12, which comes from the 4 and the negative 3, x squared, y squared. So I need to think of two expressions which multiply out to negative 12 and add up to 4. They're going to have different signs since it's a negative product, so positive and a negative. And then they're both going to be in terms of x and y. Since they have to add up to x and y, they have to be like terms. Let's think of two expressions. We've got 6 and 2. If we were to do a positive 6 and a negative 2, we would get a positive 4xy, and they would multiply it to negative 12x squared y squared. So we'll fill in the 6xy, and then the negative 2xy. So a y times a y would give us the y squared. And we're going to need an x times an x here anyway to get us an x squared. So let's think. We've got greatest common factor here, a y, and a 2. We could factor out a 2 here, and then a 2 times 2 would give us the 4. So we've got 2y times 2y, 4y squared. 2y times some coefficient of x would give us 6xy, so a 3x. 3 times 2 is 6xy. And then 2y times some coefficient on x would give us the negative 2xy. We need a negative x, since we already have our 2 here. Negative times 2, negative 2xy. We've got the negative 2xy. And then if you notice, negative x times 3x, negative 3x squared. So this could be factored as 2y plus 3x times 2y minus x. Looking at number 6, let's fill in where we can. We've got the u squared, one of our squared terms, and the v squared. So we're going to multiply the diagonal. So we've got a u squared, v squared, and then sum up to our middle term, or what's left, the 2uv. If you don't see a coefficient, it's 1. So we're going to need two terms in terms of uv. And since it's a positive sum and a positive product, they're both going to be positive. So we're going to have a positive, positive. 1 only has factors of 1 in itself, so we've got a 1 UV and a 1 UV. And if you notice, if we add these two together, we'll get the 2 UV. So we'll fill in a UV and a UV. U times U is U squared. U times V would give me that UV. And then again, U times V again would give me that UV. V times V gives me the V squared. So this can be factored as U plus V times U plus V, which can be written as U plus V squared. Finally, let's look at number 7. We fill in what we know. We've got the 5k squared and then a negative 2n squared. So our multiplies 2, product of the diagonals, we've got a negative 10k squared n squared, and it needs to sum up to the middle term, which in this case is negative 3kn. So we've got a negative product, negative sum, so we're going to have different signs. They're both going to be terms of kn because they both have to be like terms that add up to another kn. And then they're going to have different signs, so one's going to be positive, one's going to be negative. And then they need to have a difference of 3, since we're going to end up subtracting them, keeping the sign of the larger number. We need to keep a negative sign, so this expression would have to be the larger expression. We can do 5 and 2. 5 and 2 have a difference of 3. So if we do a 5 is larger, so we've got a negative 5kn and a positive 2kn, they would give me a negative 3kn, and multiply out to negative 10k squared n squared. Let's fill in where we can. We've got the 2kn and then the negative 5kn. We've got here, we can factor out a 5k, and then 5k times k would give me that 5k squared. If you notice, I factored out the 5 that was common to both of them and the k that was common to both of them. 5 times k is k squared. K times what would give me 2kn? Well, I'd have to multiply by 2n. 2n times k is 2kn. And then 5k times what would give me negative 5kn? Well, I'm going to need a negative, and I'm still missing the n, so the negative n times 5k would give me negative 5kn. And if you notice, negative n times 2n would give me the negative 2n squared I need. So factored form of this would be 5k plus 2n times k minus n. So if you notice, box and blocks still works for factoring even if we have more than one variable.